Hello student, in the last lecture we have seen examples in question number 1 and 2 in exercise 8.1. Now we will take question number 3 in exercise 8.1. Find all the points of discontinuities of function f of x equal to greatest integer function x on the interval minus 3 comma 2. Here, so this function is called as a greatest integer function. So the definition of the greatest integer functions. The greatest integer function is denoted by this symbol for any real function. The function rounds up the real number down to the integers. Functions rounds off the real number down to the integers less than the number. It is also known as the floor function. This greatest integer function is also known as floor function. So here the solution of these examples. So given this greatest integer function on the interval, for the interval where x belongs to here, x belongs to this minus 3 comma 2 here. So that is this function f of x equal to, so the first here minus 3 for this interval minus 3 comma 2. Here given function is the value of this function is minus 3 because this function is greatest integer function. So its value is greater than minus 3 and less than minus 2 here. Yes. Then if this function, the value of this function is minus 2, whenever, so which is greater than minus 2 and less than minus 1. This function, its value is minus 2 if this type of interval which is a semi-open, semi-closed. So here its value is greater than minus 2 and less than minus 1 here. If its value is minus 1, when its value is minus 1, if this semi-open, semi-closed interval minus 1, 0. If this interval here its value is minus 1 if it is greater than minus 1 and less than 0, because 0 is greater than this minus 1, less than 0, greater than minus 1. Its values, the function, when this value of this function is 0 for this interval, if this interval is 0 comma plus 1, greater than 0 and less than plus 1 here. And if the function, the value of this function is 1, if the interval 1 comma 2 here, which is greater than 1 and less than 2 here. So now we will check here the continuity of this point or this greatest integers minus 2, minus 1, 0 and 1 here. So now the continuity. At x equal to minus 2. Consider the continuity. Consider here. Continuity of or at x equal to minus 2 here. So therefore, we consider this function. For this point minus 2, we consider these two functions. This first function and here this second function. So we apply a limit to this function on both sides as x tends to minus 2. And first of all, here it is less than minus 2 and it is greater than minus 2. That's why we take this. So left hand side limit to this function because it is less than minus 2. And that's why we will take here this left hand limit as x tends to minus 2 for this function is here. Its value is minus 3. The function is minus 3. And so therefore it is equal to limit of a constant. It is a constant function. So the limit of a constant is constant. It is minus 3. Then also we take this second function because only here it is minus 2 point here. Minus 2. So it is here it is greater than minus 2. It is less than minus 2. That's why limit of function f of x as x tends to plus it is greater than minus 2. That's why we apply right hand side limit to this function f of x equal to minus 2 is equal to limit of function is minus 2 x tends to minus 2 plus here because it is a right hand side limit. Its value is greater than minus 2. And so limit of a constant is constant. And so therefore left hand side limit of this function is the value of left hand side limit of this function is minus 3 and the value of right hand side limit of this function is minus 2. So therefore from this, so left hand side limit of this function is not equal to right hand's limit of this function. So limit of this function. So left hand side limit is not equal to right hand side limit and that's why its common limit. Therefore its common limit is as x tends to minus 2 f of x does not exist. Limit does not exist. Why? Because left hand side limit is not equal to right hand side limit at x tends to minus 2 and therefore f is discontinuous at x equal to minus 2. Given function is discontinuous. Similarly f is discontinuous at other integers values of x are other values. Here it is other value is minus 1, then 0 and 1. Minus 1 comma 0 and 1. And hence we have shown that all the points of discontinuous of this function are greatest integer functions. So these are the minus 2, minus 1, 0 and 1. Then next example, discuss the continuity of the function f of x equal to in modulus 2x plus 3 at x equal to minus 3 by 2 here. So actually this is the absolute function. So we have to given the function is absolute function or in modulus sign. The given function is in modulus sign. That's why its values are two values. Its possibilities here two possibilities because if it is given in modulus sign in absolute value, it is plus or minus. If x is greater than x, the values of x is positive, then it is positive. If we take the values of x is negative, means is less than, then it is negative. So here given function f of x equal to in modulus 2x plus 3. So here if we take its values is positive for x is greater than or equal to minus 3 by 2, then we take positive value. Or when we take the function is negative, then its interval is less than minus 3 by 2. Okay, so first of all we take this first. Therefore function f of x equal to 2x plus 3 for x is greater than equal to minus 3 by 2. So here x is greater than equal to minus 3 by 2. So it means that we take x is greater than, so we take right hand side limit to this function. X is equal to minus 3 by 2, so we have to find the function of that point by f of minus 3 by 2 also. So first of all we find this function of that point. Where there is x we put minus 3 by 2, because we have to find f of minus 3 by 2, and after that we find right hand side limit of this function. So it is 2 into minus 3 by 2, x is minus 2 plus 3, and so 2 will get cancelled. It is minus 3 plus 3, so it becomes 0. Call equation first. Function of that point, the values of function of that point. Function of that point means it is function of minus f of minus 3 by 2. The values of f of minus 3 by 2 is 0. Now we find right hand side limit. We will take limit of f of x as x tends to minus 3 by 2 plus right hand side limit of 2x plus 3 as x tends to minus 3 by 2 plus here. So apply limit. 2 into minus 3 by 2 plus 3. So again 2 will get cancelled. It becomes minus 3 plus 3. So it is 0. So the right hand side limit of this function is, its value is 0. Call second equation. And also we take negative value for this interval. If this interval x is less than minus 3 by 2, so function is negative here. For minus 2x plus 3 function f of x is equal to 1 for x is less than minus 3 by 2. So therefore apply left hand side limit to this function because it is less than. Function f of x as x tends to minus 3 by 2 minus is equal to limit of minus 2x plus 3 as x tends to minus 3 by 2 minus. Take this minus sign before the limit or apply directly here. Minus 2 into minus 3 by 2 plus 3 minus 2 will get cancelled, minus 3 plus 3 is 0, and so it is 0. So the left hand side limit of this function is also 0. Call third. So from equation first, second and third we get right hand side of these three equations are same, 0 0 0 here, 0 0 0. That's why left hand side is also same. So the right hand side limit of this function is equal to left hand side limit of this function x tends to minus 3 by 2 minus is equal to function of that point, and so therefore function f is continuous at point x equal to 0 at x equal to minus 3 by 2 minus 3 by 2 या पॉइंटला हे फंक्शन कंटिन्यूअस आहे. Hence we have to discuss the continuity of the given modulus function. Next question, test the continuity of the following functions at the points or interval indicated against them. So here points indicated against them, here this function, so we have to check its continuity at the point x equal to 2 here. So here given for x is not equal to and x equal to 2 means we have to apply limit as x tends to 2 to this function, and we have to give one f of 2 for x equal to 2 means we have to give one f of 2 equal to 1 by 2. Function of that point is 1 by 5 given f of 2, the value of f of 2, function of that point f of 2 is 1 by 5. So we have to give one call equation number 1. Now we find its limit. Now limit of this function as x tends to 2 here is equal to limit x tends to 2 x minus 1 minus x minus 1 raised to 1 by 3 divided by x minus 2. Okay. So here the value of a root is 1 by 2. So means we write in this way, or I'll put here directly x tends to is x minus 1 raised to power 1 by 2 and x minus 1 raised to power 1 by 3 divided by x minus 2. Now put this x minus 1 equal to y here, and so therefore x equal to, take this minus 1 in the right hand side, is plus 1, y plus 1, and as x tends to 2 first interval, whenever we put any function then interval changes to that function. So that's why as x tends to 2 पुरानी इंटरवल x टेंस टू 2 तो चेंज होगी y टेंस टू 1 हेयर. ओके, जब जब पुट करेंगे तब तब फंक्शन की इंटरवल चेंज होगी. ओके, सो देयरफॉर आवर फंक्शन, सो लेफ्ट हैंड साइड एज इट इज रहेगी. सो देयरफॉर लिमिट ऑफ f of x as x tends to 2 is equal to, here we put only in the right hand side, so limit as y tends to 1, interval changes here. So x minus 1 put y here, y raised to 1 by 2, and minus again here x minus 1 put y raised to 1 by 3 here, divided by x means here y plus 1 minus 2 here, and so therefore it is equal to limit as y tends to 1, y raised to 1 by 2 minus y raised to 1 by 3 divided by plus 1 minus 2, it is minus 1, y minus 1. Now again here it is y here, that's why we add this here. There are two functions, we add this plus 1 minus 1 in the numerator here. So limit as y tends to 1, so y raised to 1 by 2 minus 1, this minus y raised to 1 by 3, and then it is plus 1. So we add this here minus 1 and plus 1. in the numerator, and this minus y minus 1 is as it is. And so therefore limit as y tends to 1, this y raised to 1 by 2 minus 1, we take minus common from these two terms. When we take minus common, so it remains y raised to 1 by 3 minus 1, minus into minus it is plus, and take it is also divided by y minus 1. Now there are two functions in numerator here, that's why we have to divide separately to each and every functions. So therefore limit as y tends to 1, y raised to 1 by 2 minus 1 divided by y minus 1, and another function minus y raised to 1 by 3 minus 1 y minus 1 here. So here we write the power of 1 is 1 by 2, because here it is the power of y is 1 by 2, and here power of y is 1 by 3, that's why we adjust the power of 1 is 1 by 3 here. So therefore it is 1 by 2, it is 1 by 2. Or in the next step we add this here. So therefore it is equal to, and also take limit separately, limit of y raised to 1 by 2 minus 1 divided by 1, we add this power of this one as y tends to 1 minus limit as y tends to 1. So second function y raised to 1 by 3 minus 1 raised to 1 by 3 y minus 1. And here we use this formula here, since limit as x raised to n minus y raised to n a raised to n upon x minus a into x tends to a, and so therefore it gives a n into power into a raised to n minus 1. So here a means, this a means 1, x means y, n means 1 by 2, and here x means y, a means 1, n means 1 by 3. Okay, that's one. By using this formula here, so we write this right hand side of this. So n is 1 by 2 into a means it is 1 to the power n minus 1 minus, here n means 1 by 3 into a means 1 to the power n minus, n means 1 by 3 minus 1. So anyhow power of 1, so it is 1. So 1 to the power 2 1s are 2, minus 2 plus 1 minus 1 by 2. It is minus 1 by 2. Minus 1 by 3 into 1 to the power 3 into 1, it is minus 3 plus 1 minus 2 by 3. Here the power of this 1 is minus 1 by 2, power of 1 is minus 1, 2 by 3. So its value is 1, its value is 1 also. That's why it is only 1 by 2 minus 1 by 3. And so therefore here the value of this equation, 3 3s are 1, 3 into 1 3, and 2 into 1 2, 3 minus 2 it is 1, and so it is 2 3s are 6 LCM. So it is 1 by 6. It is 1 by 6, but here it is 1 by 5. F of 2 is 1 by 2. Limit of that function is 1 by 6. It is limit of that function f of x as x tends to 2 is equal to 1 by 6. Call equation second. So from 1 and 2, from 1 and 2, from equation 1 and 2, right hand side are not equal, therefore left hand side also not equal, therefore limit of that function as x tends to 2 is not equal to function of that point f of 2. F of 2 is 1 by 5 and limit of that function is 1 by 6. Therefore f is discontinuous. Therefore f is discontinuous. F is discontinuous. At x equal to 2. F is discontinuous at x equal to 2. So in this way we test this function at x equal to 2. So at x equal to 2 this function is discontinuous. Now the second example in question number 5. So function f of x equal to x cube minus 8 divided by root of x plus 2 minus root of 3x minus 2 for x is not equal to, and for x equal to the value of this function is minus 24. So means we have to give one f of 2 is minus 24 and we have to find the limit of that function. If this limit of that function, the values of limit of that function is equal to function of that point, its value is minus 24, then it is continuous, otherwise it is discontinuous. So first we have to given f of 2 here, function of that point is given minus 24. Call equation first. Now we have to apply limit. We apply limit to this function as x tends to 2 here. Okay. F of x is equal to limit of x cube minus 8 as x tends to 2 divided by root of x plus 2 3x minus 2. Okay. Here in the denominator there are, this is the irrational function, that's why we rationalizing the denominator. Rationalizing the denominator here is equal to limit as x tends to 2 x cube, we write this 8 or 8 by x plus 2 minus root of 3x minus 2. We rationalizing the denominator here. So x plus 2, due to this minus it is plus 3x minus 2 divided by same, divide and multiply, x plus 2 plus root of 3x minus 2. So multiply numerator into numerator, denominator into denominator. Here it is limit as x tends to 2. So x cube minus, we write this 8 in 2 cube here. Cube of 2 is 8 here. So because x cube here, and take this term of irrational function as it is here in bracket, and in the dv in the denominator here, when we multiply this root of x plus 2, it is only x plus 2. It removes square root sign, then plus into minus it is minus, and again here same term in the square root sign, that's why it is simply 3x minus 2. And so therefore it is equal to here, it is equal to limit as x tends to 2. So here the factor of this x cube minus 2 cube is like a cube minus b cube. The factor of a cube minus b cube. So a minus b, and then a square plus 2ab plus b square. 2 square is 4 here. And this term as it is here. This function as it is x plus 2 plus 3x minus 2. And in the denominator here, x plus 2 minus 3x minus plus 2. So here x minus 2 x square plus 2x plus 4 x plus 2 plus 3x minus 2. So here plus x minus 3x, it is minus 2x, and 2 plus 2, it is 4. It is equal to x tends to 2. These factors are same. In the denominator, we take minus 2 common here. Minus 2x minus 2. Minus 2 into minus 2 is plus 4 minus 2x. And so this x minus 2 factor, cancel this. Take this minus 2, 1 by minus 2. Before the limit, it remains x square plus 2x plus 4 and square root of 3x minus 2. And so therefore we apply the limit to both function here. So directly here, 2 square, it is 4 plus 2 to the 4 plus 4. And here it is 2 plus 2 plus 3 into 2 minus 2. It is minus 1 by 2. 4 plus 4 plus 4. It is 12. 12 into here. 2 plus 2 is 4. And the square root of 4 is 2. And 3 to the 6 minus 2, it is 4. Again square root of 4 is 2. And so it is equal to minus 1 by 2. 2 plus 2, it is 4. 4 12 ja. 48. 2 1 are 2. 2 2 are 4. 2 4 are 8. So minus 1 into 24. It is minus 24. So limit of that function is as x tends to 2 is equal to minus 24. So call equation second. And so from equation 1 and 2, 1 and 2 we get. So right hand sides are equal. So therefore left hand sides are also equal, means limit of that function is equal to function of that point, and therefore f is continuous. At x equal to 2. So the given function f is continuous at x equal to 2. So now remaining example in this question 5 you may try to solve at home. Today we will stop here.